Okay, we're gonna start with problem number 1, or problem number 4, and it goes like this. It's asking the limit as x goes to 1 of this equation. So first what we'll have to do, or first what I did was I added these fractions like that, and then I had to check if L'Hopital's worked. So if you plug in 1 on top here, that becomes 0. That also becomes 0, and on bottom, that's 0 and that's 0. So overall, it's 0 minus 0, so we can do L'Hopital's. So what we'd have to do is take the derivative of the top and the derivative of the bottom. And as you can see, that's 3 minus 2 over x over 1 over x times x minus 1 plus ln of x. And now if we plug in 1, it'd be 3 minus 2 over 1, which is just 1. And 1 over 1 times 0 plus 0, which is 0 on the bottom. So it's going to be 1 over 0, but since we're dealing with limits, that tends to infinity. That's problem number 4. Problem number 5 is asking the limit as x goes to 0 of e to the x plus x to the x 2 over x. So on this one, I set this limit equal to y, a variable, and I took the log of each side. So here on the left side, we had ln of this equation right here to the 2 over x. But since this is a log, we can bring down the exponent to multiplication. So I canceled out this and brought it right there. So 2 over x became 2 over x. So now we have to check if L'Hopital's works. So inside the ln, it'd be as x goes to 0, right? So e to the 0 is just 1 plus 0. So ln of 1 is 0. So 0 on top and 0 on bottom. So we can do L'Hopital's. So we take the derivative of the top, which would be the derivative of the peanut divided by the peanut. So it's e to the x plus 1 over e to the x plus 2 times this out here, this times this coefficient. So 2 times all of that, all over the derivative of x, which is just 1. So that comes out to 2 times 1 plus 1, which is 4. 4 over 1 plus 0, which is just 1. So 4 over 1 goes out just to 4. But we have to remember that we set that to ln of x. So 4 equals ln of, or 4 equals ln of y. And we have to get rid of this ln. So we exponentiate, and we can cross out here, and the answer left is e to the 4. Okay, this last one, I'm not sure if I had to do, but I did it just in case. Okay. This last one's asking from -1 to 1, the integral of 5 over x squared dx. So first what we're going to do is, as you can see, this denominator can't be 0. So we're going to set a variable, a limit of a variable that goes to 0. So in this case, we have b. The limit of b goes to 0. The limit as b goes to 0 of the integral of this, and the integral of 5 over x squared just comes out to -10 over x cubed. And basically, it'd be limit of b goes to 0 of -10 over x cubed from -1 to b plus the same thing, limit b to goes to 0 minus 10 over x cubed as b goes to -1. But in this case, they're going to be symmetrical. They're going to be the same, so we can just multiply by 2. On to the next step, we distribute this right there, and it'd be -10 over b cubed plus 10 over 1 cubed. which, if you see, is just, since this goes to 0, it'd be a 10 over 0, which just tends to infinity, plus 10 all times 2, which is just infinity.